Okay, welcome back to this spooky edition of the Software Circus. We are 3 hours in, but the good news is that we have 7 hours to go of talks, panels, lightning talks, and all sorts of other activities. I hope you all joined in with the networking time we just had, saw some of the lightning talks, and also practiced carving pumpkins, because of course we're going to have the drawing of the contest, or the winners at least, for that a little bit later. A few quick announcements before we get into the next talk. Again, there is a code of conduct for this event. If you feel like someone has breached that code of conduct or you want to read it, go to Brella, click on more, and you can see it in there. You can report breaches of the code of conduct either on Slack to Carla, Sam, or Teresa, or you can, okay, here we go. Thank you, Jake. Please go away now. I'm doing the code of conduct bit. This is the important bit. Get out. Out. Sorry about that, everybody. Good. Report those on Slack, or you can do softwarecircus@container-solutions.com. If you want to see what's coming up next after this, lots of activities, including more music, chair yoga, DJ sets, cocktail masterclasses, etc., etc. You can find all of those either on Brella or on softwarecircus.io. Okay, that's that. Up next, a speaker I'm particularly excited about today, Holly Cummins from IBM, with her talk, Blood-curdling Tales of Microservices, Misadventure, DevOps, Dread, and Grisly Governance. Holly, are you ready?
I am, yeah, thank you so much.
Good. I've now fully banished Jamie, so you can...
We're good to go, it's all okay. No more mishaps. So I'm Holly Cummins, I'm an IBMer. I work in a services organization within IBM called the IBM Garage. And of course, because we're a consultancy, we see quite a lot of scary things. So I want to share some of the things that have made us particularly go, oh, don't do that. So I want us to be a bit interactive as well. So I know we've had some Slido polls through the other ones. So I've got a Slido poll. So you can either scan the QR code with your phone, or you can just go to slide.do and you can enter that QR code. And we should see if anybody's out there, we should start to see these moving. So we're seeing not much yet. I'll make small talk. I'll give it 10 more seconds while we wait to see. So we've got user error. So we've got 6 folks out there, 8, 10, 11, and we've got sort of a good mix here between the alive and the undead. Oh, but we're shifting towards alive. Cool. So I think we've established that that this thing is on, which is cool. So I want to talk about sort of some of the anti-patterns that we see with cloud and with cloud native. And one of the first problems that we see is just that we're not really even sure what we're trying to achieve. We know we want to go to the cloud for sure, and we want to be cloud native. But when we sort of investigate a bit more, well, why? Then it sort of becomes a little bit unsure. Are we going to the cloud to save money? Are we going to the cloud because we want to move faster? Are we going to the cloud because we think it will make our employees happier? And all of those are perfectly good reasons to go cloud. But if if we're not really sure what we're trying to achieve, then we may not do the systems thinking that allows us to get everything in place rather than just a piece of technology. So really we have to sort of step back and say, what problem are we trying to solve? And once we know the problem, then we can try and figure out the optimum solution. And often when we talk to clients, it seems like the problem that they're trying to solve is that they don't have enough microservices. So we sort of, a typical pattern for a conversation is that we'll be talking to the client and they'll say microservices a lot, but we become aware of this sort of ghostly presence in the room. And then we realize, then it sort of, eventually it comes out and they say Netflix. And they're not talking about coupling, they're not talking about coherence, but they're talking about Netflix an awful lot. And that's a good red flag that maybe we haven't thought deeply enough about why we're doing microservices. And I want to be like Netflix isn't a good reason to do microservices. And in general, microservices, they're not a goal, they're a means. And you can do microservices and not actually achieve anything like what Netflix achieves. And you can also not do microservices and achieve some really great things. So it's about that step back to say, well, what problem are we actually trying to solve? And the problem we're trying to solve almost certainly isn't we don't have enough microservices. I heard a story that we spoke to a bank, and they had this sort of great big COBOL estate, and they weren't going very fast. And so they said, you know, we're going too slowly. Our competition is eating us up. We need to get rid of this COBOL, go to something more modern, have microservices. And we said, yeah, great. That seems like a really good idea. You know, can't see a problem with that. And then they added, our release board meets twice a year. And at that point, if your release board is only meeting twice a year, it doesn't matter how many microservices you have, your speed is going to be gated by that release board. So that's the thing that you have to fix first before you even think about your architecture. And if you sort of don't get the whole thing right with microservices, and if you're locked into this system where you release all your microservices at once, then you don't actually have that sort of beautiful microservices dream. What you've got instead is you've just got a distributed monolith. And a distributed monolith is kind of like a normal monolith, except it's way, way worse. So don't do that, it's not going to help you. And the thing about the distributed monolith is with a normal monolith, there's some things that are maybe not so great, and there are some things that it does really well. And one of the things that it does really well is it gives you that nice synchronous guaranteed communication within the monolith, and it gives you the compile time checking, so you have the type safety, so you have some of these other things. And if you get rid of those and you don't get anything in exchange back, that's a bit of a loss. So in general, you know, when we're thinking about microservices, there's a lot of good reasons to do microservices. There's also good reasons not to do microservices. So if it's a small team, then maybe you don't need that kind of organizational autonomy. If you're never planning to release these things independently, what's the point? If you need to think carefully about how they're going to communicate and about some of those the stuff that goes between the microservices. So if a service mesh sounds like it's way too hard, if it's way too complex, then often what people end up doing instead is they say, oh, I couldn't possibly have a service mesh, that's way too much work. Instead, I'll roll my own service mesh. And that's not necessarily less work. So in either case, you still have this complexity and this maintenance burden as well. And another good reason not to do microservices has to do with the domain model. Sometimes there just aren't these nice seams in the domain model. And so then at that point, maybe a monolith is the way forward. And particularly if you don't get the domain model right, if you don't get the seams right, then you get one of my favorite things, which is cloud native spaghetti. So I was called into a project and they were having problems and they were using microservices. And when I looked at the code, I was sort of, there was a lot of it. And it was all the same. So they had this domain model, this object model, and it was common across all of the microservices. And there was about 20 classes, there was about 70 fields in each class. So there was just this mountain of data. And in order to avoid coupling, they'd cut and pasted it between each microservice. But the problem was there still was that coupling. And so what they were experiencing was that anytime anybody touched one of the microservices, all of the others broke. So it was just this sort of pile of spaghetti, and they didn't have any help from the IDE. They didn't have any help from the compiler to help them sort it out. And it has to do really, again, with that domain model, because the microservices dream is that you have each of your little microservices and you have domain models, and the domain models match up really sort of quite nicely to the microservices. So one microservice has one domain. But what was happening in this case was the domain was common across all of the microservices, and there just wasn't any splitting in the domain. And so then it just ended up in this big spaghetti, horrible mess. And ultimately, I think sometimes because we're distributed, we have this idea that because we've gone distributed, we're decoupled. But of course, those two are not synonyms. It is possible to be very coupled while being distributed. And ultimately as well, you can never eliminate coupling in a system. It's just always going to be there. You can manage it, you can reduce it. But these things, if they're going to talk to each other and have a meaningful conversation, there is going to be some coupling in that interaction. And so it's about how do we understand the coupling? How do we make sure that we don't have really hideous surprises in the coupling? And if we don't get that right, then we end up with a lot of problems. So unless we have the operational maturity to be able to handle microservices, it's going to be a nightmare. Because the thing, it's sort of obvious, but the thing with microservices is that there's a lot of them, and they're going to need some special techniques to manage. They're going to need special techniques to say, is it up? Are they talking together? What's going on? And a traditional ops organization using traditional ops techniques may really struggle to deal just with the number of moving parts in a microservices environment. And so you really, you've got to be bringing in, as well as just the microservices, you've got to be bringing in a lot of the new techniques that go with the microservices. So you've got to have the observability, you've got to have the SRE, you've got to have that approach to automation that SRE bring in terms of, if it moves, automate it. But one of the other things that we see is that automation is expensive and automation is really skilled. And so it's tempting to acknowledge the need for automation, but kind of say, we'll sort out our architecture first and then we'll come back to the automation. We'll do automation next week. And then what that means really is that we're not able to deal with the system that we've created. So one of the things I hear a lot is our ops isn't automated. And that's where SRE and that sort of automatically automating approach to ops comes, it becomes really essential. But another thing that I hear all the time is our tests aren't automated. So we're doing microservices, and then when we finish all our microservices, we have a team of testers, and they go and they spend 2 weeks doing end-to-end testing, and then we think we're okay to release. And when I hear our tests aren't automated, what I actually hear is, we have no idea if our code works. It might work, it might not. At some point, hopefully it will start working, hopefully before we release, but who knows when that's going to be. And that's kind of sad. Because the thing is, there's always going to be bugs. And if we're not in a position to cheaply discover those bugs, they're just going to multiply in the dark corners of our code. And so if we're doing microservices, I mean, no matter what, but especially with microservices, you need those automated integration tests. And Integration tests are expensive. Integration tests, they're expensive to write, they're expensive to run. So probably as well as the automated integration tests, what you really want to be looking at is automated contract tests, because they'll give you that confidence in the interactions in the system with much less sort of management overhead and pain than the integration tests. So you want a small number of integration tests, and then you want a bigger number of contract tests. One of the other problems we see with automation, of course, is that, you know, automation, it is hard. There's a reason that we don't all have loads and loads of automation. It's expensive to set up. And then once you get it set up, it needs maintenance. And if you don't maintain it, then you end up with these sort of automations that almost worked once, and then now they've just been left to rot, they've been neglected, and now they're either useless or worse than useless. So on the same project that had the scenario where every time they touched one microservice, everything broke. When I arrived, the first thing I did was I looked at the builds. And the build was red. And I said, oh, hey, everybody, look, we've got a problem, the build's red. And they said, oh yeah, that build's been broken for a few weeks. And so we end up with this sort of broken window situation where if it's a novel occurrence for a build to be red, and if people have time, they'll fix it. Once builds start to become red by default, then nobody feels any urgency to fix it. And then the build stops becoming a useful indicator of build quality because it's red most of the time. And the other thing that I think sometimes contributes to not having that sense of urgency to keep the build green is that we don't have that sort of prominence of our build results. So we don't have like a build radiator or something like that. So we don't actually know if the build's broken. And so then of course we can't fix it. It shouldn't be a big effort to go find the build results. It should be right in our face, either with, you know, something that's always on, or a traffic light, or that kind of thing. So what we see again is just this sort of problem with the build. So let's talk about your build. So how many of us have passing builds? And how many of us know we've got passing? So we've got most of it is passing, great. Does that count as green? I think that's where probably where a lot of us are. I think I might have yeah, a broken build. And we've forgotten to check. I think with so many of these things as well, there's such a gap, isn't there, between what we'd like to be doing. In an ideal world, we'd have this perfectly green test build that gives us really great coverage and that we look at all the time. But what we actually see is that there's sort of other fires to fight, and we kind of know what's wrong with the build, and it's really hard to fix, and it's just quite hard to sort of get it sorted out. And so then we end up in this situation where our build stops becoming a really trusted source of truth, and it becomes a headache, which is, these things happen. So yeah, we've got, so about a third of us are in the really virtuous thing of having green builds, and of the rest, a quarter of us don't know, and a quarter of us have kind of almost green builds. And the sort of the problem with the builds where we don't give our build as much love as we would like, and we don't give our build as much trust as we would like, leads to another problem, which is that I like to call it the not actually continuous integration and continuous deployment. So I always feel a bit nervous when someone says to me, we have a CI/CD. I think, we're going to have a problem, because that tells me that probably there's a lot of code on people's laptops, or maybe in source control, but off on branches, and they stay there for some time. And the thing is, CI/CD, it's not a product. It's not like continuous integration isn't a product. Continuous integration is a verb. It's something that you do. It's a behavior that you have. And so no matter how much Jenkins, no matter how much Tecton you have, if you're not actually continuously integrating, it's not continuous integration. And so what I see is these sort of patterns where we have CI and we say, I'll merge my branch into our CI next week. Well, if it's only going in once a week, it's not continuous. And then when we think about, the sort of the delivery and the deployment side of it, we get, I hear sort of CI/CD, 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 and then they say, and we'll re-release every 6 months, CI/CD, and I'm like, well, that doesn't feel very continuous. So more polls. What, for you, what is CD? And our options are, I've never heard of it. What is this CD thing of which you speak? Am I in the right conference? Or, sorry, I shouldn't judge. We all come from different backgrounds, and there's some pieces of jargon that are super well known in some places and not so much in other places. Or the other, often it's used to mean continuous delivery. And by that, we're thinking we're getting to staging. And then after we've got to staging, using the continuous delivery, then we manually release. Alternatively, maybe it's continuous deployment. So we're deploying to prod, but maybe that doesn't actually mean release to the public, that maybe we've got a distinction between deploy and prod. Maybe it's continuous deployment, which just means it's going to prod, and there's that release as well. It could be continuous doom because it's Halloween and just it's this sort of constant source of, oh, that happened in the CD. Oh, that happened in the CD. That's nice. So I'm interested that we've got no votes for continuous delivery, so getting to staging, but no further. And we've got quite a lot of votes for continuous deployment. So we're actually getting it out there. That's interesting, because the definition that I most usually hear is continuous delivery, but I like that continuous deployment definition much better. Cool. So let's go on. But I think what we're seeing on the poll maybe is slightly different, but often, in the ones where, we release every 6 months, we merge once a week, then, it's continuous, but it's not meaning continuous in any definition of the word that makes sense to me. So for you all, how often is continuous? So let's look at the code side of it first. So on your continuous integration, how often do you push to main? So if you pushed every character, that is technically continuous, but it's also ridiculous. A few times an hour is pretty hardcore. It's pretty good. A few times a day is pretty good. I think if you're talking about trunk-based development or trunk-based delivery, the line that they make is once a day. So you can say that you're doing trunk-based as long as you're doing it once a day. So we've got a few going once a week. So we have those longer-lived branches. We've got nobody going once a month or once every 6 months, which is good. When I first joined IBM, it was about 20 years ago, and I was on the team. We were working on the sort of the WebSphere application server, the it was a large product, and it had a complex distributed team developing it. And someone very sincerely gave me, and we had advice, because we had a build call, and if you broke the build, you turned up on the build call, and it ran 6 days a week, including Saturday, and you did not want to be on the build call. And so they said the best way to avoid being on the build call was to not break the build. The best way to not break the build was to save up all your changes locally and push every 6 months. So we've moved on a bit as an industry since then. Okay, so let's talk about CD. So that continuous deployment that people are doing, that pushing to prod, how often does that happen? So again, if it's going every push, that's super hardcore, but it's super good. If it's going once a year, that's that more traditional cycle. A lot of products still do once a quarter. Some teams do it on the sprint boundaries, so the iteration boundaries, whether it needs it or not. That's the sort of the pace on which we push out. Other teams do it more divided by when the feature's ready. That's when we go out. So we're seeing sort of less, sort of a mix here between every push, which gets a cookie, every epic, once a week, every user story. So yeah, mix on this. Yeah, a lot of that, yeah, a good number of once a week, which is a pretty healthy cadence, and every push as well. So when teams are reluctant to push, often I think the thing that's stopping them is we can't ship until we have more confidence in the quality. So we need to do that manual cycle because we didn't actually have the automation to allow us to know if things were working. And then what that sort of leads us to is this sad thing, which is the software crypt. So the software has been written. It might work great, but we don't know, we don't have those structures in place to allow us to release it. And so it just sort of sits on the shelf in the vault, not able to be released. And so when people say to me, we can't actually release this, often they've sort of said it in the same tone of voice as we couldn't actually murder our dog. It's sort of, and then I kind of want to drill down and say, well, why is releasing such a terrifying, scary concept? What can we do to make releasing more boring? And often it has to do with, again, that systems thinking, that part of the culture has gone on, but the rest of it hasn't. And so the architecture review board is scheduled for a month after the project's ready to ship, and then it sort of drags everything down. Or we have that problem with the microservices where we don't have that ops maturity. So we have to release all the microservices at the same time. And then of course there's the quality thing, which is we have no idea if this works. So of course we can't release it until we do a lengthy phase of testing. And then sometimes it has to do with features as well, that we have something that's sort of half baked, and we don't want to anger users by shipping something less than a perfect package. So we can't ship until every feature is complete. But of course, with microservices and with cloud native, the whole point of that architecture and if our features are too scary, if they're too half-baked, there's a lot of things that we can do. So things like deferred wiring, things like feature flags, they allow us to do a deploy without doing a release. We can also do things like, maybe we do want to do a release, but we want to get that feedback. So we want to do a release to just a small group of people. So we do the A/B testing, or we do the canary deploy. And again, that needs a fair amount of ops maturity. But if we can do that, we're in a really good place. Another problem we see with cloud is the locked down, totally rigid, inflexible, uncloudy cloud. So I heard a story that we sold people provisioning software, and it was supposed to provision things in 10 minutes. And it actually ended up taking 3 months. And when we investigated, it turned out it was because they put an 84-step pre-approval process on that software. So it's all about, you know, the processes. And so we have this beautiful cloud that allows us to go fast, and then we put all this governance around it, and it breaks my heart. So we heard another story that a client was going to change cloud provider, and we asked why. And the reason was because they had so much sort of procurement stuff around their first cloud provider. They hoped if they went to a second cloud provider, they'd have a little bit of a window before that procurement stuff built up, which is of course not the right reason to switch cloud provider. But we do end up with these sort of walled gardens. I heard from another client, and you could access the cloud providers or you could access the internal services. You couldn't access both. So if you wanted to access both, you needed 2 machines. So of course, what ended up happening was all their developers left. But of course, that governance is there for a reason, which is that often the cloud makes it so easy to provision software, but we have no idea how much is there. And we end up with these zombie workloads. And it's a big problem. So, I mean, I've done that. I've created clusters and then forgotten them. So I heard from a telco yesterday, and they had 28 cloud instances or maybe 35, and they weren't sure which meant that they had no idea. And that's where you get these sort of heavy governance structures coming in. So I think things like finops, I think things like multi-cloud management will help here and allow us to bring that sort of DevOps automation ideology into something which has been traditionally a bit more governed and heavy. And with that, I'll stop. So I don't know if we've got time for questions.
Hey, Holly, thank you so much for that talk. First of all, my compliments on the slides. I think they may be the best themed slides I've seen all day, but I've only seen half of the talks. Unfortunately, we are 2 minutes over. We're already into the chair yoga. So I'm going to encourage you all to find Holly. There we go, Holly_Cummins on Twitter, or in the Slack, or Umbrella later if you have some questions. So much content to look at there. I'm sure there must be some questions coming through. Holly, thank you so much for today. Up next in track 3 is chair yoga. 15 minutes after that, we're going to our next round of talks. Thank you and goodbye.